guys, welcome back to my YouTube channel. In this video we're going to discuss on how to calculate a centrifugal force when the belt thickness is omitted and the belt thickness is considered. Right, so we've given example 4 here. Example 4, reduce for we have flat belt. We have given this is a felt plate, is not a V belt. Felt belt must be installed between a motor and machine. The density of the belt material is this 1300 kgs per cubic. The speed of the driving pulley is 1350 rests per minute. The diameter of the pulley is this 280 millimeter. The belt thickness, we have thickness which is 4.5 millimeter, and the belt width is 240 millimeter. Calculate the centrifugal force exerted when the belt thickness is omitted, is not included, when the belt thickness is considered. We want the centrifugal force, which is TC. Right, so allow me to change this color. I like black. So yeah, this is what we have, guys. So I can grab, maybe let me just write the data for you guys very quickly. You can see data here. What do we have? With a density there of 1300, right? Then with the speed whereby it's 1350 rests per min. What do we have again? We have the pulley diameter there, which is 280 millimeter, and we have the thickness is 4.5 millimeter. Then we have the width, which is 240, width 240 millimeters. So yeah, so number A, we have nicely asked to calculate the centrifugal force, which is TC, when the thickness is omitted. So fine, we know that we know that TC is equal to what, actually, guys? Is mass, isn't it, multiplied by velocity squared. So it's supposed to have a mass first. You are not given the mass, then you're supposed to calculate the velocity. Okay, so let us calculate the mass. What is mass? The mass, it's what is volume multiplied by density. We have discussed this, whereby the volume is like area multiplied by length multiplied by density, whereby area is width multiplied by what? By thickness. Then multiply by length multiplied by what? By gravity, by density. That is our mass. Then remember, the length, we take it as 1, always 1 meter. I've discussed about this. We must take it as 1 always. The width we are given there, but as you can see, it's in millimeter. If you divide by 1000, you'll get this to be 0.24 meter. Just like that. Also this you divide by 1000. Everything you divide by 1000, that to be in meters. So width will be 0.24, as you have seen. When we divide, the thickness will be 0.0045 multiplied by 1. Guys, 1. The length, always use 1. The density is also 1000. It's 1300 right? 1300. It's the same as, yeah, let me not be friends, 1300, like that. And that is 1300. So you may punch that on the calculator, punch this, then you have to find to get the mass. Mass will be 1,404. Remember, must be in kg per what? Per meter. Remember, we only take it the length as 1 per meter. We have took that as like that. So we have this. Now we are done with this. The goal again is to find what? The velocity. So the velocity, guys, is equals to pi d multiplied by what? By n over 60. Remember, be careful here on the diameter. Be pi. They said the thickness is omitted, is not included. Just the fancy word, is not included or not considered. So if it's not considered, we'll take the diameter of the pulley, which is 280, we divide by 1000, which would be 0, a 0 will be 0,28, multiply by this, which was 3500, like this. If I'm not mistaken, like this here, then divide by 60. Then what will be the velocity? Remember, will be 19,79 meters per second. The velocity is measured in that meters per second. So we have this. Now we can calculate TC, mass, V squared. The mass we had that was 1.04 multiplied by the velocity, which is 19,79, but we square this velocity. This is what supposed to, if you punch that, centrifugal force will be 549,87 newtons. This is our centrifugal force there. So let's go to B. We know that to B, he said the belt thickness is considered now. So that means everything will change. If the belt is considered, what will change? It's a velocity, because the thickness, you only use thickness on the velocity either way. Okay, then the velocity is the only velocity that will change. Remember, now will be pi multiplied by effective diameter multiplied by n over 60. Effective diameter is equals to diameter of the pulley plus thickness. So it will be pi into d plus thickness multiplied by that 60. Then v will be pi. The diameter of the pulley, it was 0,28. The thickness was 0,0045. The speed, it was 1350. Then we divide this by 60. Right. So yeah, you remember that here it was our thickness. Remember, here it was, we've divided 4.5 by 1000. Here it's our diameter. The speed is here. So yeah, this is what we have substituted there. Then therefore, if you punch that, let's check what you have. Velocity there is 20,11 meters per second. But we are not done. We're supposed to calculate the centrifugal force. The mass will be the same, won't change. Only the velocity that will change. The mass will be the same. We are still using the same belt, isn't it? So there's nothing happened there. So this will be like this. you punch that. So yeah, this is what we'll have, guys. So thank you for watching. Please do not forget to subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video. Feel free to like and to share and to comment. All the best.